All right, welcome. Today we're going to pull back the curtain on the internet itself. We're talking about the secret language that powers literally everything you do online. Every click, every search, every single thing.
Have you ever really thought about it? I mean, it feels like magic, doesn't it? You type something into your browser, hit enter, and boom, a whole universe of information just shows up. But what you're about to see is that it's not magic at all. It's a set of rules, a protocol that makes our entire digital world spin.
And really, that's the big secret. The entire web is just one giant conversation. It's this constant chatter, this back and forth between your device, what we call the client, and some powerful computer out there, the server. And the language they all agree to speak? It's called HTTP, the Hypertext Transfer Protocol. So, here's what we're going to cover. We'll start with why HTTP is the web's native tongue. Then we'll break down that core request-response conversation. We'll look at the actual rules of engagement, and then tackle its biggest, most interesting problem, statelessness. From there, we'll see how HTTPS locks it all down, and finally, why knowing all this is so critical in system design.
Okay, first up, the web's default language. Look, if you're building anything on the web today, whether it's a simple website, a mobile app, or a complex system, you absolutely have to get this stuff. It's the foundation for, well, for everything.
So what is HTTP? Just think of it as the official rulebook for the web. It's the set of rules that tells your browser exactly how to ask for stuff, and how the server on the other end is supposed to answer back. Without this shared grammar, the web would just be total chaos.
All right, so let's follow one of these conversations from start to finish. We're going to trace the entire journey of a single request, from the moment you click a link to the second the page loads on your screen.
Think about it like this. You're at a restaurant. Your browser is you, the customer. You tell the waiter what you want. That's the request. The waiter takes your order to the kitchen. That's the server. The kitchen prepares your food and sends it back out. That's the response. And then you get to enjoy your meal. That's your browser rendering the page. That's it. Client requests, server responds. That is the heartbeat of the entire web.
And what's really cool is when you look under the hood, the request and the response are structured almost identically. The request starts off saying what it wants. Get me the page about users. The response starts off with its status, HTTP/1.1 200 OK, which basically means you got it, everything's good. Both have headers for extra context, and both can have a body to carry the actual data. It's this really elegant mirrored dialogue.
Okay, so if this is a language, it's got to have words, right? Verbs, replies, and it does. That's where HTTP methods and status codes come into play. These are the specific words that actually make the conversation happen.
These methods are basically the action words, the verbs of the web. When you're just reading an article, your browser is sending a GET request. It's just fetching data. When you sign up for a new account, that's a POST request. You're creating something new. PUT is used to update something that's already there, like changing your profile info. And delete, well, I think you can guess what that one does.
Now for the server's replies. This is where status codes come in, and they're actually pretty simple once you see the pattern. They're all grouped by the first number. Anything that starts with a 2, like 200, means success. Here's what you asked for. Anything in the 400s means you, the client, messed up. That famous 404 error, that's the server saying, you asked for something that I just don't have. And anything in the 500s means the server itself has a problem. Oops, something broke over here on my end.
All right, we need to talk about something that is maybe the most important concept here. And it's a little weird. By design, HTTP has no memory. It's what we call stateless. And this feature is both its greatest superpower and its biggest weakness. So what does stateless actually mean? It means every single request your browser sends is treated as a completely new and isolated event. The server literally has amnesia. It has no clue who you are or what you asked for even a millisecond ago. Every single time you click, it's like you're meeting for the very first time. And this is the paradox. This amnesia is a huge blessing for building massive websites. Because any server can handle any request, it's super easy to add more servers and scale up. But it's a total curse for user experience. I mean, if the server forgets you instantly, how do you stay logged into your bank account? How does your shopping cart remember what you added? So, how do we fix this? How do we give the web a memory?
Well, this is where engineers get clever. We build state on top of this stateless protocol. We use things like cookies, which are like a little name tag your browser wears. Or we use something called a JWT, or JSON Web Token. You can think of that like a temporary ID badge. With every single request you make, you flash that badge reminding the server, hey, it's me again.
But you know, having all these conversations out in the open on the public internet, that's a pretty big security risk, right? We need a way to make them private. And that is where that little s at the end of HTTPS comes in.
So, a lot of people think HTTPS is some brand new protocol. It's not. It's just our good old friend HTTP. The only difference is that the entire conversation is put inside a secure, encrypted tunnel called TLS. It's like writing your messages, but then putting them in a locked, tamper-proof envelope before sending them across the internet. So, how does that secure tunnel get created? It happens in a split second through something called the TLS handshake. First, the server shows your browser its ID. It's called a security certificate to prove it's the real deal. Then, they securely agree on a secret one-time password called a session key. From that moment on, every single message sent back and forth is scrambled using that key, making it complete gibberish to anyone trying to eavesdrop.
Okay, let's wrap this all up and talk about why this is such a big deal. Why do we go through all of this? Because truly understanding HTTP isn't just trivia. It is a genuine superpower when it comes to designing and building modern software.
See, this stuff isn't just for loading websites anymore. It is the invisible backbone of almost all modern software. It's how all those little microservices in a big application talk to each other. It's what load balancers use to spread traffic around. It's how API gateways protect the front door. It's how caching works to make things fast. It is the glue holding everything together.
And this quote, this really hits the nail on the head. When things go wrong in a big, complex system, when an API feels slow, or you get a strange error, or there's a security hole, so often the root cause traces right back to a misunderstanding of these fundamental HTTP principles.
So when you boil it all down, the entire, massive, complex web, it's just a series of simple conversations built on these elegant rules. Now that you understand the web's secret language, the only real question left is, what are you going to build with it? Thanks for diving in with me.